Hello everyone, here is your teacher Neha, and in this video I am going to explain the oxidation state or oxidation number of the central metal atom. Okay, and in this video we will also practice some example by taking the examples of complex compound, and I will tell you how to find out the oxidation number of the central metal atom. So watch till the end and learn with me. Okay. So let us start. Oxidation number and oxidation state. Oxidation number of the central metal atom, you can define it as a charge. This is a charge that it carries as calculated by assigning appropriate charges to ligands. Okay, we assign appropriate charges to ligands and then equate the sum of the charges on the central metal atom and the ligands equal to charge on the coordination sphere. What does it mean? Suppose a complex I am taking CuNH3 whole 4 SO4. Okay, now here copper is the central metal atom and SO4 is the counter ion, and these are the species which are coordinated to the copper central metal atom with a coordinate bond. Now here inside the coordination sphere, the sum of the charges carried by these species, for example copper and the ligands, here only one ligand is present, so the ligand and the central metal atom together, we calculate the charge and equate it with the charge outside the coordination sphere. Okay, so here sulfate ion is -2 charged, this is -2 charged ion. So since the compound must be electrically neutral, the complex ion or the coordination sphere should carry +2 charge outside it. Okay, so how we calculate the charge on the copper metal? By adding the charges present inside the sphere and then equating it to +2. Okay, let us do here. Will take the charge to be calculated at X. This is the Cu, plus ammonia is a neutral ligand, so the charges on this ligand is 0. Okay, and how many ammonia is present here? 4. So into 4, and this must be equal to charge outside the coordination sphere, that is equal to 2. Alright, so X comes out to be +2 because it becomes 0, so it comes out to be +2. So here the oxidation state of copper is +2. Right. Let us take the example of this nickel carbonyl complex. Okay, so if we have to find the oxidation state of this metal nickel, we assume it equal to X. Suppose it is X, then the ligand carbonyl, here carbonyl also is a neutral ligand, so the charge on it is 0 into 4 carbonyl molecules are there, and this must be equal to charge outside the bracket. Now here the complex is a neutral molecule. Okay, so the charge outside is 0, so X comes out to be 0. So you find that nickel here present in 0 oxidation state. Okay, here 0 is the oxidation state of nickel. Now when we write the name of this complex compound, the oxidation state of the metals central metal atom is mentioned in the name of the compound, and it is represented by writing in Roman numeral. Suppose a metal is +3 oxidation state, then we write 3. If it is +2 oxidation state, we will write 2. Okay, whatever is the oxidation state of the metal, it is represented in its name by writing a Roman numeral in the parenthesis. Right? Now oxidation state and coordination number, these two words are totally different, है ना. Now oxidation states refers to the charge present or the present on the ion on at which oxidation state it is present, but the coordination number, it refers to the total number of coordinate bond formed with the ligands. Okay, so here if you find the coordination number of nickel, it is 4. Here 4 ligands are attached to nickel with the coordinate bond, so the coordination number is 4 and oxidation state is 0. Okay, let us take one more example. Potassium ferrocyanide. Right, here we have to calculate the oxidation state of iron here. So K, potassium is the simple ion, it is a counter ion, and this is the complex ion. So if we remove this potassium, we will find that there are 4 potassium and it is plus, so there must be 4 negative charge outside the complex. So we can say that this is K positive and the complex is FeCN6 4 negative ion. Right. So now we can calculate the oxidation state of this iron. How? Assuming it X, then plus cyanide. Cyanide is carrying negative charge, 1 negative. So 1 negative for cyanide ion. And how many cyanide ions are there? There are 6. So we will multiply this minus 1 with 6. And this will be equal to charge outside the bracket, and that is minus 4. And this comes out to be X minus 6 equal to minus 4, and X comes out to be plus 2. So here iron is present in plus 2 oxidation state. Okay, it is a ferrous ion here. If you have to calculate the coordination number, you can easily see that there are 6 ligands attached to iron. So the coordination number here is 6 and oxidation state is plus 2. So these two words are totally different, and you must carefully, when calculating or when asked in the exam, you must be careful about writing the numbers. Okay, that's all for this video. Thank you.